So in order to get quantitative data for our filter, we're going to use a spectrometer. And the spectrometer allows us to read out on the x-axis here wavelength, and on the y-axis transmittance. So basically for each wavelength it tells us what percent of light at that wavelength is being transmitted through our filter. So the apparatus looks like this. A fiber optic cable coming through here. Our sample goes in here, and then another fiber optic cable going out. And there's a white light being passed through this cable. It diffracts from our filter, and then it goes into the other cable. And at the end of that is a spectrometer that measures the percent transmittance at each wavelength. So I'm going to place my filter in the path of the beam here. And then we're going to be able to see on the screen, and you could ignore all of these lines, these are just something that a coworker of mine was working on, but what I want you to notice is this peak right here. Okay? So that is the spectrum of my filter. And it's probably hard to read the axis here, but right around here is about 620 nanometers, and the transmittance is about 75–80%. Okay? So what this tells me is that at 620 nanometers, almost all of the light is being transmitted, and at other wavelength, almost none of the light is being transmitted. And we know that 620 nanometers is actually that pink color that we were able to see visually before. So this is giving me quantitative data about how my filter works.